Hey guys, very quickly, we're going to be looking at your chemical equations. Oh yes, and chemical equations, this is our lesson 6. Who is excited? Yeah, let's go together. Now, having looked at everything about your chemical symbols, we've also looked at your chemical formulas. It's high time to chill with chemical equations. And in chemical equations, the quick question is, what is your chemical equations? Don't forget this, that an equation is a shorthand form of a chemical reaction. So the shorthand form of a chemical reaction, what is it called? It is called your chemical what? Equation. You know, while we're looking at your chemical symbol, we said that the shorthand form of representing your elements, right, is called your chemical symbol. For instance, H, instead of us saying hydrogen, or you just say it's your word H like this, right? And this H there represents one atom of that element, and that is your symbol. So what represents one atom of an element? It is called your symbol that we looked at other chemical symbols. And then we left elements, we came all the way to your compounds. We said that the shorthand form of your chemical compounds, what is it called? Of course, it is called your chemical formula. That's how I said that your elements are represented by symbols, but your compounds are represented by your formulas. So the shorthand representation of chemical compounds, right? For example, okay, NaOH, sodium hydroxide. Is it an element or a compound? Compound, that shorthand form is called your chemical what? Formula. Is different from your chemical equations. What's your chemical equation? It is the shorthand form of a chemical what? Reaction. For example, now, I just tell you that when hydrogen reacts with oxygen, water is going to be formed. What I've just said is a chemical reaction. But how do we represent it? Of course, very simple. It is when hydrogen, right, this is gas, go and react with your oxygen, and then this is your gas. What is it going to bet? H2O is going to be formed, and then probably, let's say this is gas, right? Now, how many hydrogen here? 2. How many oxygen here? 2. How many hydrogen here? 2. How many oxygen here? 1. So if I balance this now, here is now 4 hydrogen, and then here is now 4 hydrogen as well. Oxygen is 2 here, oxygen is 2 here, balanced, right? What I've just given you now is your chemical equation. Now, what is chemical equation? It is the shorthand form of representing a chemical reaction. I want to represent a chemical reaction. How do I go about it? The easy way to write it is your chemical what? Equation. But that's not all about chemical equation. There is a lot to it. You must note this, that chemical equation consists of 2 parts. How many parts? 2 parts. Number 1 is called the reactants, which is always on the left-hand side. And of course, hydrogen, this whole guy, hydrogen and oxygen, like this, coming together, they form the reactants. Because you need the reactant to combine before they go and form the product. So chemical equation is made up of 2 parts. Number 1 is the reactant, which is usually on the left-hand side. Of course, this here is the left-hand side of the equation. And then the second part is your water that is now formed. And that is what forms the products. And the product is on the what? Right-hand side. So now listen to this. In a chemical equation, a balanced chemical equation, I'm coming there. The right-hand side must be equal to the what? Left-hand side. Why is it so? It's so because a balanced chemical equation obeys the law of conservation of mass or matter. And you remember the law of conservation of mass or matter, right? Oh yes, we state that matter can neither be created nor destroyed, right? In a what? In a chemical reaction. But you can always convert them from one form towards another. So a balanced chemical equation where there is rearrangement of their elements, we obey the what? Law of conservation of what? Your matter or mass, which is in accordance. Hey. With the law of what? Conservation of what? Energy. Share the feeling. Oh yes. As we move together, you will understand chemistry depth. Now let's go together. Don't forget this, that if A and B is combining together to go and form my C and D, where is the reactant? The reactant is the A plus B. This is the reactant. C plus D. What is C plus D forming? That is the product. Also, you must note this, that the reactant and the product, there is something that must link them together. And what link them? It is an arrow that is pointing to the products. And you can see that this is the arrow there. Where is the arrow pointing to? Product like this. Not that I now go and say A plus your B for example, it's not like this. Shade the wine. But it's possible that I have my A plus B, and then I have this like this, giving me C plus D, right? Yes. This kind of arrow is telling me that the reaction is in equilibrium. And that's a separate topic, right? Chemical equilibrium. I'll treat that when we get there. I'd like you not to forget this very fast, that an equation is said to be balanced, right, when the total number of atoms on each element in the reactant equals the total number of atoms on each element in the product. Simple. 1 to go. When is an equation said to be balanced? An equation is said to be balanced when the total number of atoms of each element in the reactant is equal to the total number of atoms on each element in the product. That equation is said to be what? Balanced. Number 2, when is an equation said to be balanced? An equation is said to be balanced when it obeys the law of conservation of mass, or the law of conservation of what? Matter. Does it make sense? And this law of conservation of mass or law of conservation of matter is one of the 4 laws in the laws of chemical what? Combination. And don't forget this, that you must understand that in the balancing of chemical equations, there are a couple of things that we must watch out for. Are you ready? Yeah, let's go. Now, please, number 1, write out the correct reactants and products and link them by an arrow. So, if I'm to balance a chemical equation, I'll write out the correct reactants and the correct product, and then I'll balance them with what? Arrow. Okay, let's say, for example, formation of ammonia, which is your ABA process that is using the formation of your ammonia, right? Where nitrogen is going to combine with my hydrogen. If nitrogen is combining with hydrogen, what is it going to give me? Of course, it's a link them with an arrow. It's going to give me what? Ammonia, NH3. Now, this equation is not yet balanced, but please, in writing or balancing a chemical equation, what do? Write out the correct reactant. Is my reactant here correct? Yes. Nitrogen is correct. Hydrogen is it correct? Yes. Of course, is the product correct? Yes, correct. And then I've linked them with what? An arrow. The next step they say we should do is check out, right, to ensure that the number of atoms of each element in the reactant and the product are equal. Ensure that they are equal. Now, the question is this. How many nitrogen do I have here? Nitrogen here on the reactant side. Nitrogen here is how many? 2. N2, right? That's 2 atoms. But on the product side, how many nitrogen do we have there? Just 1. N alone, that's 1. So, in balancing that, I'm going to put 2 here. Sure, you see now, very simple and direct. Now that our position 2, is nitrogen balanced on the reactant and the product? Yes, so it all balanced, it all clear. But look at the reactant. How many hydrogen do we have there? Hydrogen is 2 on the reactant. On the product, how many hydrogen do we have there? You know, hydrogen is more like there is 2 in front, right? And then there's now H and there's now 3 from this product side. If you multiply 2 by 3, how many do we have? 6. That's 6 hydrogen. If you watch, hydrogen here is just 2 on the reactant, but on the product is already 6 atoms of hydrogen. Balance it. In balancing that, what will I do? I'll come and position 3 here, right? That means hydrogen is now 6, 6. Balance, bro. Look at step 3 that you must watch out for. Please, if the number of atoms of the elements in the reactant and products are not equal, what do we use? A coefficient is used. For example, let's say our N2 plus your what? H2 that we balance, and then we got your what? Your NH3. How do we balance it? We say add 2 here. Nitrogen is now balanced. Then hydrogen come and add 3 here. You see this 3 and these 2 that we have added there. What are they called? They are called coefficients. What are they called? Coefficients. And you are not going to disturb like these guys that are down here. I'm coming there. I will show you the law that governs this one very squarely. What we are going to be disturbing is the coefficients, the values that are in front. Again, what is your root 3? If the number of atoms of the elements in the reactant and product are not equal, what happened? A coefficient, whether 2, 3, or 4, whatever number you like, is written in front of the formula. And that is exactly what we have done. We have added 3 in front of hydrogen. We have added 2 in front of what? Ammonia to balance it. And then what is your root 4? Do not change the subscripts. If I write N2 like this, You see this down to, it is called subscript. Do not for any reason go and change subscript of the formula. When you change subscript, you are totally wrong. Do not change the subscript. Again, what did I say? Do not change the subscript of the formula. Changing the subscript will alter the formula. When you have done that, you are totally wrong. You can change any other thing but subscript. Baba, leave them for where you did. If you understand these 4 things with me very quickly, please look at a WAEC question. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb and Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. Your question say balance the equation. Balance the equation. What do we do there? Very simple. What happened there is your nitrogen, right? Of course, we have done this already, plus your hydrogen. That's going to give us your what? NH3. This is ABA process that is using the formation of ammonia. And of course, nitrogen is always gas. Hydrogen is what? Gas. Ammonia is also what? Gas. But they did not stress us with gas. You don't need to go and write their states. Now, here is it. How many nitrogen here? 2. How many nitrogen here? 1. Come and position 2 here. Nitrogen is balanced. Hydrogen here is how many? 2. Hydrogen here is how many? In the product side, 6. 2 times that 3 is 6. Right? Come and position 3 here. How many do we now have? 6. Because 2 times 3 is also what? 6. Listen carefully. Is nitrogen balanced? Yes. In the reactant. Is nitrogen balanced in the product? Yes. It is also 2. Hydrogen, how many years? 6. Hydrogen, how many years? 6. Is it balanced? Yes. Give me the balanced equation. It is your N2 plus your 3H2 to go and give us your what? Your 2NH3. Everything here now is what? Balanced. Once you have done that, you are out of there. This is the correct answer. N2 plus 3H2 to give you a 2NH3. And you are out. You are correct. Look at the second question. WAEC question. And they gave us hydrogen sulfide reacting with your, this is your hydrogen sulfide here, reacting with your what? Your sulfur 4 oxide to go and form water and sulfur. Balance the equation. What do we do there? Your hydrogen sulfide, H2S, plus your SO2 will go and give you H2O plus your sulfur, right? Yes. How many hydrogen do we have there? 2. Hydrogen here is 2. Is it balanced? Balanced. What about sulfur? How many sulfur do we have there? Sulfur here is 1. Sulfur here is how many? Sulfur here is 2. Okay? Sulfur is not balanced. So when I add 2 here, just they follow me. Is sulfur balanced now? Sulfur in the reactant is 2. 1 plus 1, 2. In the product, how many is sulfur? 2. Balanced. What is left? Sulfur here has been balanced. Oxygen. Oxygen here is 2. Right? Is oxygen balanced in the product? No. Oxygen is not balanced from the product because oxygen in the product that we have is 1. So what will I do? I'll come and add 2 here as well. But you see, once I add 2 to front of hydrogen, oxygen is now balanced in the product, oxygen is balanced in the reactant, but it has already distorted everything about hydrogen. Hydrogen is no longer balanced. Hydrogen is no longer balanced. How many hydrogen do we have here? Hydrogen is now 4, right? On the product side. So to come and balance it, if I come and add 2 here on this reactant side, now let's check it out. Is hydrogen balanced on the reactant side? Is hydrogen balanced on the reactant side? Yes. Hydrogen is here 4 reactants. Product 4. Hydrogen is balanced 4 4. Sulfur on the reactant side is now 2 here. 2 plus 1, that's 3. But on this other side here, sulfur is how many? 2. Sulfur on the reactant is 3. Sulfur on the product is how many? 2. Okay. Let's leave sulfur aside. Let's check hydrogen and oxygen. If they are balanced, we can easily balance sulfur. Okay, now let's go. How many hydrogen on the reactant side? 4. Right? How many hydrogen on the product side? 4 as well. How many oxygen on the reactant side? Oxygen is 2 on the reactant side. How many oxygen on the product side? 2 as well. The only thing that is not balanced now is sulfur. Because on the reactant side, sulfur is 2 plus 1. That's 3. On the product side, it is 2. So to balance it now, you see, I need this guy that is sulfur 2s to be 3. So if I am to take this out, it will just be plus what there? Instead of 2s, right? can I just use plus 3s there? Well, let's rewrite everything. It will give me 2H2S plus SO2 to give me 2H2O plus 3S. Let's check whether we are correct. How many hydrogen here? 4. Hydrogen here. 4. Hydrogen is balanced reactant and products. Sulfur on the reactant side, how many? 2 plus 1, 3. On the product side, 3. Sulfur is balanced. What about oxygen? Oxygen is 2 on the reactant side. On the product side, oxygen is 2. It shocked you. You don't balance. Now, this is the correct answer. And what do we have there? There is 2 here, correct. How many here? 1, nothing here. That's 1 there, right? Correct. This guy is 2 here, and here is what? 3 here. Good to go. Shay are saying it's very easy. Now you try this one out. Look at Jamb 1980 question 9. Jamb 1980 question 9. Jamb brought this wonderful question. Which of the following reactions is correct as written? Which of them is correct as written? Option A. Now, iron chloride is combining with your ammonium hydroxide, right? Now, to come and form your iron hydroxide and then your ammonium chloride, is that equation balanced? Now, listen carefully. Just use your eye fast and do a normal quick check, and then you are going to see how many iron do we have there. Iron here is 1. How many iron do we have there? Iron here is how many? 1. You see this 3 here. When you have Fe right into OH3 like this, let me shock you. Iron is 1. This 3 here is for OH. The 3 outside, you see that OH is in brackets, so it is OH that's in the bracket that own that 3. So how many oxygen do we have? 3 there. Here from this equation up here. How many oxygen is here? 3. How many hydrogen is here? 3. Iron is what? 1. So you see, very simple. Follow me. Come out. They show you things. How many iron do we have here? Iron here is 1. Iron here is 1. Iron is balanced. Or you just say which of the following reaction is written correctly? The one that is balanced. Any one, even if it's one thing that you're wrong, leave the another option B. Now check chlorine. How many chlorine do we have there? 2 chlorine here, right? But how many chlorine here? There is big 3 outside. This 3 is affecting everything here. So that 3 is also for chlorine. That means chlorine is how many there? 3. Not balanced. I don't leave equation 1. A. I don't leave option A. I don't go. Okay, look at option B very fast. In option B, we're given this, right? Let's check whether it is correct very, very fast. How many lead is here? Lead is 1. PB is lead now. Plumbo. Lead is 1 on the reactant side. Lead is also 1 on the product side. Lead is what? Balanced. Okay. Nitrogen on the reactant side. How many nitrogen is here? 1 on the reactant side. Nitrogen is 1. See this 2 on the product side, right? If you have 2 HNO3, the 2 is affecting everything that is inside there now. How many nitrogen is there? Nitrogen there is 2. So nitrogen here is how many? 2. On the product side, nitrogen is 2, but on the reactant side, nitrogen is 1. So option A is not correct, right? Option B is also what? Not correct. Look at option C. Option C says we're giving sodium hydroxide plus your tetraoxophasic acid is going to give you your sodium hydrogen tetraoxosulfate cis and water. That's what they have given us in option C. How many nitrogen and sodium? Sodium here is 1. How many sodium? Sodium here is 1. Sodium is balanced. How many oxygen? Oxygen here is your 1 on your sodium hydroxide, but your tetraoxophasic acid, how many oxygen is there? 4. 1 plus 4 is how many? 5. On the reactant side, oxygen is 5. Go to products. How many oxygen here? 4. 4 plus 1, that's 5. Hooray! Oxygen is balanced, making sense. So, what about hydrogen? Hydrogen here is 1. Hydrogen here is 2. 1 plus 2 is how many? 3. On the reactant side, it is 3. On the product side, here is your 1. Here is your 2. That's 3. Now, we have balanced sodium. Sodium is balanced. We have balanced. Oxygen is balanced. Hydrogen is balanced, right? Let's check sulfur. How many sulfur do we have here? 1. How many sulfur do we have here? 1. Wow, making sense. That means option C, in the reactant and product, everything about option C, balanced. Look at option D. Option D here, how many sodium, how many nitrogen? Nitrogen here is how many? 2, right? Because it is 2N, that's 2. How many nitrogen here? 2. Nitrogen is balanced. Hydrogen is how many here? 4 times this 2 that is outside, that's 8. 8 hydrogen on the reactant side. But on the product side, it is just 4. This guy, Baba, you are wrong. What is the correct answer? Option C is the correct answer. Where sodium hydroxide is reacting with your tetraoxosulfate acid to go and form your sodium hydrogen tetrasulfate 6, and your water, option what? C, hooray, is the correct answer. Can I shock you something there? Don't forget that option C is a neutralization reaction. What is neutralization reaction? It is the reaction between an acid and a base to form salt and water. Acid there, tetrasulfate 6 acid. What is the salt? So what is the acid there is salt. Tetrasulfate 6 acid. What is the base? The base is sodium hydroxide. Acid and base reacting to form salt. What is the salt there? Your salt there is your NaHSO4 from option C. Option C, that's what I'm looking at. This salt here, is it an acidic salt or is it a basic salt? Of course, it is an acidic salt because of the presence of what? Hydrogen. When we get to acid, base, and salt, bro, I'll teach you there. Now, look at this 1984 question 4. Jamb 1984 question 4. We're given this sweet question there. Manganese 4 oxide react with concentrated hydrochloric acid, right? According to the equation. And then they gave manganese 4 oxide plus your X HCl to give your magnesium chloride, your chlorine, and then YH2. They say X and Y are, and we're giving option A, option B, option C, option D. Let's find X and Y. Yeah, let's go. When MnO2, right, go and react with your X, I don't know whatever that X is going to be, but X, whatever, then HCl, what is it going to give us? It's going to give you your MnCl2, right? MnCl2 plus, okay, can we take out the options, right? So that we can have a lot of space and then solve. Yeah, let's go together, bro. So what is the equation? The equation is your MnO2, right? Plus your what? Your X. Let's take out that X first. That's your plus your HCl is going to give us your MnCl2 plus your Cl2 plus your Y, just so that it's H2O that is there. Can we solve this easily and direct and see what our X and Y they are going to give us? Your Mn, manganese, it is 1 here. Manganese here is 1. That's correct. Making sense. What about your oxygen? Oxygen here is 2. Oxygen here is 1. Go and add 2 here. Oxygen is balanced on the reactant and product. Hydrogen here is 1. How many hydrogen is now here? 2. So go and add 2 here. Hydrogen is balanced. What about chlorine? Chlorine here is 2. What about chlorine? Chlorine here is 2 on this side. And then chlorine here is also what? 2 here. That means how many chlorine do we have altogether on the product? 4. But on the reactant it is 2. So we're gonna get to balance the chlorine. So, okay, let's do something very, 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 very lovely. If we make this guy here to be 4, let's make this guy here to be 4, right? If this guy is 4, what is going to happen? Check out hydrogen for me. Hydrogen here is how many here? 4, right? 4, balanced. Oh, hydrogen was not balanced originally. Now, hydrogen is balanced. Hydrogen here is 4. How many hydrogen do we have here? 4, balanced. How many oxygen? 2 on the reactant. On the product, oxygen is 2, balanced. Right? Yes. How many, start from beginning. How many manganese on the reactant? Manganese is 1. Manganese is 1. Balance. Reactant and product balance. How many oxygen? Oxygen is 2 on the reactant. On the product, it is 2. Balanced. How many hydrogen? On the reactant, it is 4. On the product, it is 4. Balanced. How many chlorine? Chlorine is 4 on the reactant. On the product, it is 2 plus 2. How many there? 4. Balanced. The question says we should get the value of X and Y, right? Okay, let's see it together. The X there, don't forget that the X is on the side of HCl. So that HCl, where do we have our HCl? HCl there is 4. That means X is going to give us 4, right? The Y is on H2O. H2O is 2. So your Y is going to give you 2. So your X is 4, your Y is 2. X is 4, your Y is 2. Let's check out the option that will give us the answer. Now, 4 and 2, that's what we're looking for. X and Y respectively. 4 and 2, no, it cannot be option A. It is not 4 and 2. Option B, 2 and 4. No, we're looking for 4 and 2. Option C, 1 and 2. Option D, what do we have there? 4 and 2. Hooray! 4 and 2 is our correct answer. That is option what? D, the perfect answer for this. Okay, look at your Jamb 1987 question 24. A powerful and a sweet, lovely question that we're giving. And the question all the way says your magnesium oxide, right, which is solid, react with your XHCl, hydrochloric acid, to give magnesium chloride and water in addition with chlorine. In the equation above, what are the values of x, y, and z respectively. How do we solve this? It's very simple, easy, and direct. Just go straight. Tell us that your MnO2 solids plus your HCl, remove the x, y, and z, remove all of them. First, when you solve, what is it going to give us? Your MnCl2 aqueous, right? Plus your H2O liquid plus your Cl2, right? Gas. Now, how do I balance this? Very simple, easy, and direct. The first thing is Mn. How many do we have here? 1. Mn. How many here? 1. Complete, correct. O. Oxygen there. 2. How many oxygen here? Oxygen here is 1 on the product side. Come and add 2 here first. Oxygen is balanced on both sides. Manganese is balanced on both sides, right? Come down to hydrogen. How many hydrogen do we have here? 2. How many hydrogen do we have here? 4, right? 4. So if I add 4 here like this, that guy is already balanced. Now, if I check out your hydrogen is balanced, how many chlorine here? 4 on the reactant side. Chlorine on the product side, it is 2 plus 2, that's 4. Balance. The equation is balanced. Easy and direct. Very easy. They say find the value of x, y, and z. Okay, well, yeah, shock me. Where is the value of x there? X is going to give us nothing but x is on HCl side. That's HCl, that's 4. Your y is on H2O. Your y is equals to 2, right? You see that this question is similar to the last one we just solved. How many chlorine? 1. Chlorine, that's your Z. Z is equals to 1. That means your 421 is the correct answer. Can we check out the one that is 421? Who is good to go? Yeah, let's go. Option A, 412. No, we are looking for 421. Option B, 1. We are looking for 421. 421. Option C, 421. Option A. What is the correct answer? 421. Option 1 D is the correct answer. Look at question 11. WAEC 2012 question 18. We're giving this powerful question. Consider the reaction represented by the following equation, and then we're giving the reaction. What is the reaction? The reaction is your CH3OH, right? That's methanol. Methanol is combining with your oxygen. Organic chemistry, the class is there, poor. Everything treated in details, one after the other, directly for you. By the time you learn the organic chemistry, man, even your pursuit TME is sorted. Jamb WAEC, everything is sorted. 100 level university too, you are good to go. Let's go. When your methanol reacts with oxygen, when you are burning methanol, what is it going to give you? Carbon dioxide, CO2, and your water, H2O. But we are giving 2 in front of this. And we have to balance this and get X, Y, and Z. How many carbon do we have there? 1. How many carbon do we have there? 2, right? Balance this, put 2 here. So 2 carbon on the reactant, 2 carbon on the product, balanced. What about hydrogen? How many hydrogen do we have on the reactant side here? This is your 3, right? 3 times 2, that's 6. This is also 1. Now listen, if you have CH3OH, how many hydrogen is here? 3 plus 1, that's 4. And then I have 2 outside. That means 2 is multiplying everything. 2 times 4 is 8. 8 hydrogen on the reactant side. On the product side here is 2. It's not balanced. Add 4 here. Is hydrogen balanced? Yes, hydrogen is not balanced. What about, again, is carbon balanced? Yes, carbon is 2, 2 on both sides, balanced. What about hydrogen? 8, 8, balanced, left with oxygen. How many oxygen do we have on the reactant side? 2 plus, that's your 2 here, 2, right? Plus another 2 here, that's 4. Reactant side is 4. On the product side, how many do we have here? Oxygen here is 4 plus 4, that's 8. 8 oxygen. But on the product side, it's not balanced. Because on the product side, I just have how many? 4. So if I add 3 here, how many oxygen is now here on the reactant side? Reactant side is how many? 6. Plus these 2 here, this oxygen, and these 2 is affecting the oxygen. That's 8 on the reactant. On the product, 8. Hooray, balance. Check it out now. What is your X, Y, and Z respectively? Your X is going to give you nothing but X is 2, right? Because of these 2 here. What about your Y? Your Y is for the oxygen side, that's 3, and the Z is what? 4. So 2, 3, 4. Correct answer. Yeah, let's check out the options and see. Option A, we're looking for 2, 3, 4. Making sense. Option B, no, 2, 4, 3. Option C, No, it's not the answer. What is option D? That cannot be the answer. What is the answer? Option A is the correct answer. 2, 3, and what? 4. Look at question 12. WAEC 2013, question 19. And we're giving this sweet question all the way. The question says, consider the reaction represented by the following equation. And then they gave us your C2H2. That's your ethane, right? Ethane, which is an hydrocarbon. You want to react ethane, which is an hydrocarbon, with your what? Your hydrogen. That's hydrogenation of your alkanes and alkynes. Aye, sapta. Organic chemistry, joke. Hydrogenation of your alkanes and alkynes. Of course, they will always bet alkanes for you at the end of the day. And that is an additional reaction. And that's one of the preparations of your what? Alkanes. Yeah, let's go anyway. When your C2H2 reacts with your hydrogen, what is it going to give us? If you watch this guy that I have here, direct bar, is an alkane. And that alkane is your ethane. If you don't know what I'm saying now, under this aspect, I'm just communicating their names of these guys. These are organic compounds. Don't bother yourself. When we get to organic chemistry, you will learn our way. What is it going to give me? C2H6 is what I'm going to have there. How many carbon is here? 2. How many carbon is here? 2. Balanced. How many hydrogen is here? Hydrogen here is how many? 1. 2. 2 plus 2. How many? 4. Right? 4. How many hydrogen is here? 6. Just come and add 2 here. Direct. When I add 2 there, this guy here, hydrogen here is how many? 2 plus 4. 6. Hydrogen here is how many? 6. Balanced. You are good to go. The question is to find the value of Y. What's the value of Y? 2 is the correct answer. But listen carefully. The name of this compound here is your ethane. Ethane. And then this compound here is your ethane. Are you getting it now? When we get there, I'll show you all of them. What is the value of Y? The value of Y is 2. Well, let's check out the option and see. Option A says 4. No way. Option B says 2. Correct. Option C. No way. Option D. So what is the correct answer? Of course, option B, 2 is the correct answer. If you get this very quickly with me, bro, you have done very, very well. And you are super good. Guess what? I'll see you in lesson 7. We are going to be learning everything about what? Oxidation number. But listen, though, before you go into oxidation number, I beg you, please, the first thing, rock through my notes. What did I say? Rock through my notes. Very, very important. Very important. Run through my notes. There are a lot of questions, right, that are there. Go and finish all of them before you come into oxidation number. We have a lot of questions there for you. And if you have done that, don't always forget to invite a friend. Tell a friend. Always invite somebody. Tell a friend that the academic surgeons are in town and you are learning with the LearnLift app. Tell somebody about the LearnLift app today. I'll see you in oxidation number very quickly. Enjoy it. Bye-bye. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.